Hey, welcome back. What you see here is a Deckel rotary table with 380mm diameter. When I brought back the transport pallet from the Weiler lathe, which was just on lease, I brought it back to Arnold. I picked up this rotary table for no apparent reason. I don't really need it. I don't have real work for it, but I was always intrigued by it because it's so big and it looks too big for the Deckel FP1. Also, it's bloody heavy. It's 56 kilograms. So lifting it without a crane is annoying at best. But it's very big. It's relatively low profile. It's sitting on some wood blocks here. So when we measure from these wood blocks, it's 11 centimeters tall, 110 millimeters. And I haven't looked into it yet. I have no idea what condition it is. It's grimy, but a friend was recently here and he started to clean it. It's always a good idea to invite friends to clean machine hardware. And well, it cleans up nicely. There are no big blemishes to the top surface. The side that he cleaned, I took a precision stone and it's really not terrible. I already removed the indexing disc and the indexing pin, but it's moving. It's very tight. I suspect it's sticky with old oil. I also have the paperwork for this rotary table. Well, for this type of rotary table. Deckel didn't give you much instructions on these items. It's a rotary table. It's 1 to 90 worm drive. 90 spins on a hand crank or 1 full revolution of the platter. And it has an accuracy of plus minus 90 arc seconds. And this is only the explanation of how to disengage and re-engage the worm drive and also how to use the direct indexing. Because this can not only be used with the worm drive engaged, you can disengage the worm like this, like on many rotary tables. The Moore rotary table does not have this option, which makes it very impractical for general shop use in my opinion. Because when you disengage the worm, and then you can theoretically free spin the rotary table if it wasn't stuck as it is. Yeah, this doesn't move by hand yet. We'll have to look into it. What I just took off, there is a large graduated dial on the circumference of the rotary table and a vernier, an adjustable vernier from 0 to 60. So this is arc minute. This is an arc minute vernier. I already took some Scotch-Brite to it and cleaned it up. At least up here. Down here it's still as I got it. So this will be fairly interesting. I'm filming this after I had taken it apart and put it back together. So this rotary table can be set to spin freely completely, and you have a large dial on circumference and a vernier to set it by a dial. It can do direct indexing with a plunger down here that indexes every 15 degrees. In combination with the lock that's used to do hole patterns or wrench flats that fit into this 15-degree pattern. And if you want to do more complex dividing operations, you have the worm drive. It's a 1 to 90 worm drive with a disengageable worm, which my other large rotary table, the Moore rotary table, doesn't have. So you engage the worm and now you can use it like a worm-driven rotary table with the usual setup with the indexing pin and the sector arms here. So you index, you use your sector arms, just like on the indexing head. And this gives quite the options. You can also take this rotary table and mount it vertically against the apron of the milling machine when you remove the table. But that's more of a specialty situation if you want to machine a casting on both sides. For example, if you have like an engine block and you want to machine the, what do I know about engines? The bearings in front and end of the block. You can machine one side and swing it around into the other one. If you do large parts, you gain a lot of travel in the y-axis. You're basically doubling your y-axis travel because you can do your machining on one side, 150 millimeters Y travel. Then you just spin it around and bring the other half of the part into the travel of the y-axis. So that's one of the reasons that I think that this large rotary table exists. Also, it has a lot of real estate for work holding, of course. So let's jump back in time and look how this rotary table looked when I picked it up and tore it down. So the underside has seen better days, and this is the locking arrangement. This large lever just tightens a large nut that pulls the platter up against the main body casting. I suspect this comes right off. Okay, this comes off. Then we should be able to undo the nut back here. Now it would be nice to be able to lift the casting off the platter, and I think I will use the overhead crane for that. So let me rig something up and lift it. There we go. Woohoo! Okay, it came way better apart than I expected, and it's in way better condition than I was hoping for. All of this in here is, you can smell this probably through your screen. This is oil gunk. The worm doesn't seem to have any pitting or rusting. The worm gear also looks in good condition. It's not bronze. It's cast iron, which I was surprised. I've seen the same rotary table with a bronze gear in here. So let's see if we can pull the worm carry out. This shouldn't be retained by anything anymore. It's just stiction. There we go. And it smells amazingly bad. Here's the worm, and due to the fact that the worm is eccentric to the center of this carrier, you can adjust the engagement depth into the worm gear, and hence that you get an adjustment of your backlash in the rotary table. So yeah, there is a lot of gunk in there that I need to get out. I don't trust this brown sludge as a lubricant. Interestingly enough, a little interesting design feature. When I pulled the table off, I noticed that this part here is loose and wiggling around all over the place, and I was already worried that the casting might be broken. But thinking about it, this hub here in the center, this is not the guiding element. This is free floating on purpose. This has side-to-side float, and this is not guiding the rotary motion of the platter. The guiding surface for the diameter is out here. That's way larger, which is also beneficial compared to the small diameter here. This large diameter matches a large bore in the base casting, and this is guiding. And this here is just for clamping. With the large thread back here and the large nut with the lever on it, it pulls the rotary table's plattern or the faceplate up against the casting and locks it in place. So that's the reason why this is floating. And the reason why it's floating is it doesn't influence the location when you clamp it. So you strictly get axial pull and no sideway loads from the clamping. So that's a clever design. I don't hate it. And over here, this is the large diameter that the plattern is rotationally guided. And we have two ring surfaces that form the axial bearing of the faceplate. Over here you can see the indexing pin. I think this can be driven out from this side. I have to look into the drawings again. The drawings for this are not great. There are two cross sections and they are very small and not the greatest of a print. Which in all honesty, all of the Deckel drawings are not that great. At least the drawings that are supplied for the customer to work on the machines. And here we have some yucky oil. And I think there is a little bit of rust in there. But so far I don't see any rust on the casting, which is fairly nice. I sprayed on some WD-40 or petroleum. I'm not sure how well this shows on camera, but this surface has been turned. There are circular machining marks all the way around. So I suspect this was either done on a very big lathe or on a jig borer or something like that, facing these two ring surfaces that form the axial bearing. Out here we have the second axial bearing surface, and there's a little bit of dirt on here that seems to form a ridge, but at least with a finger I can't tell if there is a wear step. But just from looking at it, there are still the machining marks fully visible on these axial surfaces, which makes me extremely happy. Out here you can see this ring is bolted on and pinned in place. This is the direct indexing with 24 positions, and this direct indexing ring should also be accurate to 90 arc seconds, which is not terrible. It's way less good, yeah. Great English, Mr. Stefan. Way less good than the Moore indexer, of course, Moore rotary table. And overall, I think this indexer is more of a general use, more practical general use rotary table, because it's more rugged and you have the direct indexing feature and you have the option to disengage the worm drive to free spin it, which you can't do on the Moore rotary table. Moore didn't do the disengaging worm on the high precision rotary tables because for precision reasons. That's also the reason why it's plus minus 6 arc seconds compared to 90 arc seconds. But still, this is relatively precise for what I'm doing. Funny thing is, I probably never have work that will require such a large rotary table, but you never know. And also, it has a lot of space on it to put work holding on it. On my small 150mm rotary table, when you use trap clamps, you run out of space rather quickly. So, since nobody sent me a proper large wash table, I have to do this here on my lift cart or on the bench, and it's fine. I'm not cleaning crusty hardware every day, and just a brush, some solvent and some paper will get you very far without having any special equipment. Yes, less convenient, but also one less thing to worry about. Ugh. And working with solvent gloves are a good idea. The discoloration on this direct indexing ring seems only to be dried and gunked up oil too. I think I'm going to take the gear off. Since it's pinned in place, it should go on the same way without losing any precision. But I want to get most of the gunk off before I deal with it. Okay, here is the worm gear. I will brush this off over on the bench. Here is the locking piece, the free-floating lock. And we have some gunk in here. Which is interesting because this is upside down. So it really looks good on the inside. I will also pull the direct indexing ring because the casting has ribs below the ring and they are all gunked up too. And since this thing runs with oil, I want to get most of the gunk out before I refill it with oil, because the oil will otherwise flush the dirt back into all the sliding surfaces. Not a good situation. I suspect I can't get this ring out directly because the pins don't have a thread to pull them out, just like these. But in this case I could leverage the worm gear off with 2 crowbars. But out here I can't get any purchase, so I'm most likely going to drill and tap 2 holes into this ring to push it off. Also, I marked the orientation with a center punch mark over here, so it goes back together in the same orientation. Okay, let's see. I drilled and tapped 2 M6 holes through the indexing disc. And these should allow me to press the ring off. If you design something that uses dowel pins, either specify a way to remove the pin, for example pins with a thread to pull them out, or add jack screw threads so the guy who has to do maintenance on it doesn't tear out his hairs. Pull his hairs? Yeah, I have to be a little bit careful so it doesn't tip over side to side. Okay. There we go. I found out how this piece comes out. It's pressed in from the other side. There is a recess so it doesn't slip through. So with a copper drift, we should be able to drive it through. And then you can just pull it out. And that's the index pin arrangement. What works really well to break up the dried up and hardened grease and oil in such an item is a soft brush in a rotary tool. This is a nylon brush in a NSK die grinder and some WD-40 or other solvent of your choice. And this really helps to break up and loosen everything. Then you can just get rid of the remainers with an air gun and a piece of paper towel so you don't spray the solvent all over the shop. This faceplate cleaned up extremely well. There is literally no damage or no visible wear to it, apart from some discoloration here on this inner bearing surface, but I'm not going to bother with it. This is just discoloration. On all surfaces you still can see the original machining marks, the concentric grooves from the turning or facing tool or whatever they used to do these. The only spot that needed some touch-up was here, and that's where I drilled the jack screw threads through the directing indexing ring. And I had to drill a little bit into the casting of the faceplate. That needed a little bit of deburr, but yeah, that's it. It's really clean, it's in great condition. And I'm very pleased to see that. So let's flip it around into the other side. My friend already started to Scotch-Brite half of the table. Which is very nice of him. And I'm going to do the remainder of the table. So a little bit of petroleum. The petroleum acts both as a lubricant for the abrasive and also as a solvent for the gunk. So I'm going to cut me a little bit of a piece of Scotch-Brite and go to town. And I hear you. Yes, it's an abrasive. Yes, I'm removing material. But by the time you remove any meaningful amount of material with a gray Scotch-Brite pad from a machined surface, especially cast iron, you will probably die of old age. So I'm not exactly concerned here. Let's see. So gray Scotch-Brite is a little bit like a magic trick for machine cleaning. Ugh. It's really coming out nice. A little bit of work back here and over here, but we're getting there without making a science fair project out of it. And as I mentioned, I really do not need this rotary table. This is the hobby part of my business now. This is just me enjoying machine accessories. I'm not exactly a collector because I don't. I'm not looking for complete sets of items or specific years of manufacture. I like to collect practical items. If it's not practical, it doesn't have a real reason to exist. In my shop, at least. As a tool. Yeah, this is. But this rotary table, apart from it being stupidly big and heavy, is a practical item, and one day, well, maybe there will be a part that requires a large rotary table. I mean, how practical is this rotary table? Depends. For plate work, for example, if you need to have a large plate and you need, I don't know, a rotary milled feature, this is highly practical because you have a lot of space for strap clamps all around, or if you work on a large casting and you need to do something to it, this is probably an excellent item. But if you work mostly on small parts, well, it will work extremely well because it's extremely heavy and rigid. And it's fairly accurate with 90 arc seconds of overall accuracy. Well, it's probably a pain to set up. Well, it's not since I have the crane, but still it's a heavy item to move around. But I kind of like it. These show often up on the used market for reasonable little money, because most people, they show up often in very good condition or in mildly used condition, because many people bought them when they got the machine back in the 80s or 70s, but often they didn't get used because they were so awful heavy. So you will find, if you buy an old FP1, often in the accessories cabinet, you will find a lot of unused tooling. Because it seems that very often the machine got sold with the entire accessories package, including the rotary table, slotting head, high-speed head. But very often the machines got brought in with the entire accessories package, and the machine was set up with vertical head and a rigid table, and it stayed that way for its entire duration in the shop that it was purchased for. Happened at my day job very much. So many of the accessories are often in good condition. You have to be careful when they were used for, you have to look out for rust. Coolant in both the rotary table and the indexing head are causing trouble. So that's the face, and now the circumference. As you can see, that this is all yucky. You're not a real man, you're wearing gloves. Yeah, but I'm also working with petrochemicals. And I don't want to have that stuff on my skin all the time. Different to many rotary tables, this doesn't have the star-oriented T-slots. These T-slots go straight through. And the idea behind that is when you put this Monstrosity onto 0 or 180 degrees, when you put the rotary table on 180 degrees or 0 degrees, these T-slots are in line with the x-axis of the milling machine. The rotary table itself has two keys that align it to the table of the milling machine. So that makes setups quite a little bit faster. You can pop in precision keys in the T-slots and align your work that way. So that's a nice bonus. As with all rotary tables, you have a warm drive in here. It's 1 to 90 reduction. So 90 turns on here give 360 degrees up here. We have the usual setup with an indexing pin and the sector arms. I have shown indexing with sector arms numerous times. And you can lock it in a so it doesn't engage the indexing disc, and then you can just use it like a hand crank. You have a lock down here which puts the rotary table itself in a locked position. It doesn't spin, it doesn't put any forces on the worm anymore if you take a very heavy cut. You will see in the teardown how this lock works. It's quite clever. It doesn't influence the XY position of the table at all. And I think it's a neat design. We have the option to disengage the worm, like on most rotary tables. And then we can free spin the table. For example, if we mill something like plastic, or you can go over very high feed, you can just disengage it and spin it by hand. Or when you indicate your work and you don't want to crank here for all eternity to center up your work, you can just disengage the worm and spin the table by hand to indicate your work. And also we have direct indexing. That's this knob down here. You can engage it, and then we have, I think, 15-degree increments of indexing, which is quite nice for simple work where you don't need to figure out the correct ratios for indexing discs. So that's the rotary table. There are two holes up here in the table. That's to fill the worm drive gearbox and the slideways with oils. This thing is completely filled with oil. It has a sight glass down there. And I think it's supposed to be run with ISO 68 or ISO 48 oil. No grease. Yeah, that's a rotary table. There is not too much to it. It's bloody heavy. That's also why I have the hand forklift currently here in the shop. And you want to move this with a chain hoist or a forklift. Don't lift it by hand. This will take its toll over time on your back and everything else. So let's look at the teardown and how the condition of this thing was when I got it. So that's the brochure of the FE1 milling machine. And this is still the older version with the 2 lever gearboxes for speed and feed. But apart from that, it's already very close to my machine. The motor is still the old style with the foot. The new machines have a flanged motor. The clamp of the head up there is different on the newer machines. But apart from that, it's very similar. So that's the machine horizontal. That's the internals. There it is. There is the FP1 with the rotary table, and also the huge splash and chip guard down here, which I don't have because it takes up so much room to the side and to the front since it flares out quite a bit. But as you can see, they have this rotary table on the universal table, which is not the ideal choice because the universal table is not as rigid as the non-adjustable table. Also, it eats up about 80 millimeter more sea height. But that aside, you can see that they have a fairly sized casting on here and doing work on it. The rotary table is 380 millimeter in diameter and the y-axis travel of the machine is only 150 millimeters. So with this big rotary table, you basically can double the y-axis travel of the machine by just flipping the work by 180 degrees. Also, you can mill quite big circles with this and still have place for work holding on it. So there is a reason why this big rotary table exists. The casting here is, by the way, the casting of the casting that's machined in the example here is, by the way, the casting of the optical rotary table that belongs to jig boring machines. And there are some work examples. Interestingly, there are not many examples with the rotary table. Here is the quick rundown of the rotary table. The accuracy is plus minus 90 arc seconds, which is a little bit coarser. Oh, it's the same on the... So the rotary table has an accuracy of plus minus 90 arc seconds, which is similar to the indexing head, which is also plus minus 90 arc seconds, but they also made a special version that's probably just pick and choose from a number of indexing head that they made. That's plus minus 45 arc seconds, so double the precision. So that's the rotary table. It has provision for dividing discs or indexing discs. It has direct indexing too, so you can disengage the worm, and you have 24 positions for direct indexing. There is also the option to remove this whole assembly and put on a graduated wheel and a vernier. You have also a vernier in arc minute reading that's adjustable for 0, and a lock to lock the rotary table down. And over here there is a practical application. You can see that there is quite a lot of space around this pump housing that they are boring for work holding using the UPA 3 boring head Woolhopter, and seems like they are boring a number of holes on this casting, or it appears like it. So that's all the pictures from the original brochure. Here it is, rotary table, 55 kilograms. Compared to the indexing head, which is 51 kilograms. I think the 51 on the indexer are with the overarm support. Okay, that's the brochure. Now for the Deckel technical bulletins. I have some spots marked out here too. There is the rotary table on should be a FP3 with the precision boring head on it. And they are using a sine bar back here to get a higher precision angular alignment on this part than the rotary table would allow. So that's always an option. If you do something very, very tight tolerance and you need a better accuracy than the worm drive or the direct indexing of your rotary table has to offer, you can always use a sine bar and an indicator and a bunch of gauge blocks to get higher accuracy out of your setup than the rotary table is just used as a work holding and adjustment axis. That's always an option. They kind of explain the system over here. That's the sign bar that they sold. It's a scissor type sign bar, which has a fixed base, pivot point, and a place for the gauge blocks and a roller. I made something like this years ago on a shaper. So that's my interpretation of this device. I made this during my hobby days, or very much during my hobby days. I didn't have a surface grinder back then. All the precision surfaces are done on a shaper, and I got pretty good accuracy out of it. I want to make a new one out of tool steel, hardened and ground. This is all soft, hot rolled steel. But I used it a lot, and it's kind of useful. It's a nice form factor. The newer version I want to make a little bit thinner and then overall a little bit more elegant. But it's a useful design. I used to use this quite a bit on the lathe compound to adjust the angles. So, and over here we have an application of the same rotary table on a Deckel KF duplicator or mold tracer or die sinker milling machine. They're cutting a mold that almost looks like the form for a cake. To machine those individual cutouts, they have a master model that's just one of those cutouts, and then they are indexing with this large rotary table around to get this pattern in here. Same application down here, but instead of a master model, they're using the model, the geometric. The possibility of this machine to create basic geometric shapes like circles, angled cuts, and ellipses without a master model. Incredible machines, incredible complicated. I have the manual for it somewhere. It's like a phone book. So yeah, that's the most interesting pictures that I could find for this rotary table in use in the actual literature. I hope you enjoyed this teardown and a look into why this rotary table exists as a piece of accessory for this fairly small milling machine. To be very frank, I'm not sure if I ever need to use it because I don't make those large parts usually, but this rotary table is more a case of I want instead of I need. It kind of belongs to the milling machine, and it's just a very beautiful piece of equipment. And since it's relatively thin, I can store it away in a way so it's not very obtrusive to my shop. And yeah, it's just a nice piece of equipment. Maybe I will find work that's suitable to be put on here. If not, I'm not going crazy about it either. I'm not much of a tool collector in general. I like stuff with a purpose. I don't need like 15 bench vices. But with rotary tables, it's kind of a different story. You always need the one indexing or rotary device that you do not have currently. So maybe. Thank you all for watching. Thanks for the support, and I'll be back.